Hey guys, so welcome back. Today I will be talking about what we went over in my last data science class. We basically discussed random sampling and how you can achieve it using data science. So some important things that I should mention are that this is using Jupyter Notebook and this is also using Python as the language. So if those things don't apply to you, more specifically the Python thing, if your data science class doesn't have Python, then this video probably won't be too helpful. But you know, some theory, I guess, could help anyway. So to start out, we have this data table right here. This is the code we use to load it in. It's just, you know, a table that talks about flights, and it has a certain number that indicates how long it was delayed. So this is a more specific table that shows just the flights that were to JFK, and again, it includes all the information, the row, the date, the flight number, and also the delay. So right here, the dot take method, it takes basically whichever rows you specify. So right here you would input an array, and it creates a new table using just the rows that you took from the original table. So the original table is called united. Then the dot take method takes this array from that table and creates a new table with it. So this array you could say is random. Because you are just randomly selecting the rows. However, here, well, if you look at this, basically the np.arrange method will create this array that starts at 0 and ends at the number of rows in the table, and hops forward by 1,000. So as you can see, it starts at 0, then it goes to 1,000, then 2,000, then 3,000, and so on. And that's how we get this table. And so in a way that is random, but at the same time there may be something about the 1,000th row in this data set that we don't know, such as, you know, it being, for example, the 1,000th flight is always the last flight of the day or something like that. So while this is theoretically random, it's not good enough, and we need something better that assures it being more random. So this is a step in the right direction. Here we just input absolutely random numbers, and this is what we get. And again, that is sort of random, but again, it's not good enough. There isn't enough randomness to it. At the end of the day, you're inputting the numbers, so it's not truly random, but it is better. And so right here, we step in an even better direction by basically creating a random choice from an array of 1,000. And what that'll do is it'll give you a random number, and then here we take from the table and create a new array, and we start with that random number from this array. And then again we do the same thing, we hop by 1,000, but this time instead of starting at 0, we start at a random number, and then we hop forward, and that kind of makes it more random. Because, you know, rather than being 0, 1,000, 2,000, it's a little more random. It's still 1,000 in between, but it's a little more random. I'll just run it again to show that it does truly randomly select the row. So here we have a different row that it starts with, and then it goes up by 1,000 each time. So that's pretty good. But actually, funny enough, the data science plugin that we use actually has a sample method, and that does everything for you. So obviously that is the easiest method to use. Well, this one right here is not bad at all. You know, this one is just logically way better. This one is a built-in method that gives random selections. So this is the table it came up with. I'll run it again, it'll come up with a new table. So it randomly chooses them, and this is the true random sampling method. These ones are all good. I mean, this first one right here is basic, it's alright. This one is a little better, this one is better, and this one is best. So this is the one that I would use. And then here where we kind of talked a little bit about distributions, we had a die, or a column with the numbers 1 through 6 to represent a die. Here we sampled it 10 times. This is what we got, and this is what the histogram would look like ideally. So that's an even amount, and that's using this right here. So if a histogram is created for this table, this is what it would look like. But then I guess that's the raw histogram, the proper histogram with the correct bins as made by this array right here. It basically assures, since dice are 1, 2, 3, or 4, the way that the bins work is they don't they include the starting point and don't include the finishing point, so it's logical to arrange them in this manner so that it goes by 0.5, 1.5, 2.5, etc. So it's never you're never on the overlap point. And so this is what the ideal histogram would look like from a perfectly distributed dice roll. But here we do the sample 10 and the dice roll, and we see that it's not perfectly distributed. And what that shows is that 10 is too small of a sample for that data set. It doesn't give you a good enough picture of it. So what we then do is we increase it to 100, and we see that it gets a little better, but it's still not great. We can increase it to 1,000, and we see that it gets closer. And what this is demonstrating is the law of large numbers, and that's basically a law of statistics that just says that as you do more and more repetitions of something, it gets closer and closer to what it's expected to be. So if you flip a coin, you have 50-50 odds of getting heads or tails. So if you flip a coin 5 times, you might find that you get heads all 5 times. So your distribution would be like a 5 to 0 distribution rather than a 1 to 1. So as the law of large numbers states, if you flip a coin 1,000 times, you're more likely to have a closer distribution, or closer to the correct one. It's obviously probably not going to be exactly 1 to 1, and it probably never will be exactly 1 to 1, but the more repetitions you do, the more of a chance that it gets closer to there. And then I guess there's just some more demonstration of it right here. The same business, that's just the distribution graph. As you take more and more samples, the distribution gets better. And that's pretty much all we did. This is just kind of a recap of these sampling methods. So this one is called deterministic sampling. Again, I talked about this. This is where you jump by 1,000. That one is your method is predetermined, therefore it's deterministic sampling. And then again, this one again is predetermined, so it's deterministic sampling. This one, as I said, is a little better because you're randomizing the starting point, but after that it's deterministic sampling, so it's random-ish. And then this one is the real, truly random sample. So yeah, that's pretty much everything we covered in data science today, and after my next lecture, I'll make the next video. Thank you for watching.